Hi, 803. This is the holiday version of your study guide, and we want to make sure that we are prepared for the exam on Friday. There's about 8 different things you need to know. We've practiced most of them, but I want to create a short review so that you have all of these down for your notes and ready to ask questions on Tuesday. Once again, the study guide, 803, Unit 3. The topic is linear functions, and to just give you an idea, what is slope all about? Slope is about basically the rate of change of anything. In this particular case, this is me going on a pretty much flat slope. If I am going downhill, my slope looks more and more like this. The steeper the slope, the steeper the mountain. Okay, I'll try not to do that again. In any case, a couple of essentials that you need to know. The slope formula we learned in class. The slope formula is y1 minus y2 divided by x1 minus x2. That also means the change in the rise divided by the change in the run. This is the standard form of a linear equation. The linear equation in standard form is very helpful to us because when it's set equal to y, I know the m in this position is always the slope. I know the b in this position is always the y-intercept, or where my equation will intersect the y-axis. In this little sketch that I did right here, this is my y-intercept. This is my x-intercept, but this is what I'm particularly interested in, and again, that's the b. So ask yourself the question, how do I find slope when I am given 2 points, 0.35 and -2, -6? You're not going to get any more information than that, just 2 points, and you want to find the slope between those 2 points. So I go back up to my handy-dandy formula. It will come in very useful on this test. And I substitute points in. In this case, I just have to remember which point is 1 and which point is 2. So I'm just going to use this as being my y1. So my y1 is 5. I put it into my formula. My y2 is -6. I put it into my formula. And on the bottom, my x1 is 3, and my x2 is -2. Be sure you carefully copy in when you have negatives. That's always a big problem on finding slope. So now I have 5 minus a -6 divided by 3 minus a -2. And we know when we subtract a negative, we end up adding a positive. That's the same for the denominator. When I subtract a negative, I add a positive. 5 plus 6 equals 11. 3 plus 2 equals 5. The slope between those 2 points is 11/5. You don't have to convert it. It's just rising 11 for every 5 that it runs. Okay, concept 1, slope between 2 points. Let's move on to concept 2. How do I write the equation of a line when I am given 2 points? Well, once again, the equation of any line is always going to be back in this form. Y equals mx plus b. So whatever I find, my final answer is going to have y equals m, the slope, times x plus b, the y-intercept. So let's say they give me 2 slopes. I need the slope, and I need the y-intercept. Once I found the slope, I plug it in here. The y-intercept is just going to be anything where x is 0 and y-intercept is what you calculate. So let's go on to this concept. In any case, this is a multiple choice question on this particular test. So you're going to look for something in the correct form. Y equals mx plus b. Once again, m is the slope, and b is the y-intercept. If you see something that looks like this, and this is 1, 2, and 3, 1, 2, and 3, my line looks like this. My y-intercept is right here. The name of this point is when x is 0, y is 1. Therefore, anything in this B position has to be equal to 1 because I know that this is my y-intercept. Moving on to concept 3. If you are given a graph and you are told the rate of change or the slope, those are the same, is 4, you have to choose the graph which has the slope of 4. Remember, there are two ways that we can figure out slope. One, we can use our formula. The other, we can simply count the boxes. So in graph number 1, I can see that on my x-axis I have the time, and on my y-axis I have the distance traveled. So for each hour I have gone 21. That's this point. For this 2 hours I have gone 22, etc. If I've gone 4 hours, I can calculate where I basically end up on my run. 425 would be here, but my 4 over 1 is going to give me the slope of 4, which would be the correct graph in this case. My alternative graph, which is much flatter slope, for every 1 in rise, I have 6 in run. That point is way over here, so obviously this is not what I'm looking for. In this case, my 4, in this case, I have gone from this point, which is 21, to 25, which is a change of 4, and on my x-axis, it's a change of 1. 4 divided by 1 is 4, and this would be the correct answer when I'm choosing. The fourth concept that we need to focus on. What is the equation which passes through some point, in this case they give you, let's say 5, 2, and has a y-intercept of -3. So back to what I know, I need everything in this y-slope format, y equals mx plus b. My answer is going to be in this format. So the first thing that I need to do is find the slope between these 2 points, 5, 2, and 0, -3. You can graph it, but that takes a long time. I suggest just using the slope formula. Number 5, concept 5. The primary way to tell if a function is linear is simply that the exponent of x has to be 1. It cannot be anything but 1. So you're going to see a couple of examples. Y equals 3/4 x plus 1. What's the exponent of 1? If you don't see anything there, you know that it's 1. This would be a linear equation. Y equals x over 3. There's an imaginary y-intercept of plus 0. What is the exponent of x? It is 1. This is also a linear function. Y equals x squared minus 5. This is 2, which means I'm going to have some kind of function which is a quadratic. We haven't learned it yet, but the function is going to be U-shaped, definitely not. This is not a function for the simple reason that the exponent is not 1. Concept 6. How do I know if something is a function? If you remember in class, we did a couple of different tests. The easiest test for you to know is the straight line test. You take a pencil and you pass it over. We're going to go over graph 1 first. If I pass my pencil any place along this graph, it only intersects my graph 1 time. Therefore, this straight line is obviously a function. This is the quadratic that we just looked at. Once again, if I pass my pencil over it, it only intersects my graph at 1 point. A quadratic is also a perfectly reasonable function. This is an absolute value function, and if I pass my pencil over it, it's like so, it will intersect at one and only one place. An absolute value function is also a function. This is a step function. We haven't learned them yet, but there's just a few little things you need to know. Remember that the closed circle means that the function includes that point. So if I pass my pencil over that first point, no problem, passes fine. When I get to this second point, my pencil is actually intersecting 2 closed circles. So this is not okay. Not okay. This is, because of these 2 points, this is not a function. If the only point were this one, the closed circle and open circle, it would have been fine. But once you have one infraction of the domain rule, this is not okay. This is not a function. You might also be able to ask if something is a function based on data in a graph. And remember, we're simply mapping x to y. For every x, there can be only one y. So 1 to 2, 3 to 4, 5 to 6. This is okay, and this is a function. My function 2, I have 1 maps to 2, but 1 also maps to 3, which means it is not okay. Not okay because I have my x mapping to 2 different y's. And you can cross that one off your list. Concept 7. You need to be able to read and interpret a graph. And when it says read and interpret, they're going to give you some pictures of graphs and ask you what's happening at each particular interval. The one that we looked at before was a pelican looking for fish. The pelican starts on the water, flies up. At this point, the altitude, the height of the bird does not change. The bird is soaring looking for fish. He sees a fish, and his altitude automatically drops right back down to 0. That's over time. Another type of graph you might see is a walk in the park. And so on this, I have my distance on the y-axis, and I have my hours and time. So I'm kind of ambling along here, going at various rates. I'm not going at a constant rate, but I am continuing to be further and further away from my home. If I start, my distance is 0, I'm further and further away from home. But this particular interval between, let's say, time 1 to 3, between time 3 and time 4. So sometime between time 3 and time 4, I didn't go any distance at all. My distance remained constant. And I simply stopped. I was either taking a break or having lunch. Then I continued on, and I have, again, not a constant rate of walking. I'm going at a variable rate, but the most important thing to see is where I stopped. You might also see something really peculiar looking like this. The only thing you really need to know about something like this is I have a linear function here because it's a line, but this is a decreasing linear function. It decreases. And in this particular case, I'll use my blue, it's linear, but it's increasing. In this case, my slope, or my rate of change, is positive. So when the line points up, it's a positive rate of change. When the line is pointing down, it's a decreasing rate of change. This particular interval right here, it's not linear at all. It's in the shape of a quadratic. So in this case, the yellow portion is not linear. And in this case, from this point to this point, it is nonlinear and negative or decreasing. From this point, it is increasing but nonlinear. So you can see on this graph, I have decreasing linear, increasing linear. The first portion of the yellow is nonlinear decreasing, nonlinear increasing, and then once again, this last piece of my graph is also linear, but it is decreasing. So I would need to know someplace between here and here, my graph is nonlinear and negative. Final concept, and then we are all done. And in this case, you've given some data about 2 different companies, and the 2 different companies want your business, so we're trying to figure out which one we're giving our business to. I decided to use an airline company, and it wants me to write, to create a linear and proportional equation from data in a table. That sounds scary, but what you're doing, as always, you're just finding the slope or the rate of change. So my first airline, let's call it Airline A, is Easy Air. And if I want to travel 100 miles on Easy Air, I will pay $200. If I want to travel 300 miles, I'm going to pay $600. So we can pretty quickly see that if I divide my y by my x, I get my k.